right, good afternoon, everybody. We're going to go ahead and get started as people are joining in right now. If you noticed, we are recording this, so something should have popped up and let you know that. Thank you for joining us for the second session in the Mitigating Pathogen Transmission webinar series. Again, my name is Kelly Huff, and I'm the marketing manager, and I'm based in our Phoenix, Arizona office, and I help coordinate customer trainings and events. Because we are recording this, we will be able to send a copy of the recording, the PowerPoint slides, and the question and answers probably early next week, like I did this week for last week's session. So if there is anybody that missed it, feel free to share it with them. Since we do have quite a few people on this webinar, we will have everybody muted and we'll handle all the questions through the chat box. If you have a question at any time, please type it into the chat box. We will stop a few times throughout the webinar to review and answer the questions. We do want to be respectful of everybody's time so that if we do go over, we will stay on and answer them, but we will make sure that we get you a copy of those after if you do have to jump off right at the scheduled end time. For introductions, I'm not going to get as detailed as I did last week. So Dan Hahne is our sales engineer and our resident educator based out of our Phoenix, Arizona office. And Alan Anaya is a senior sales engineer out of our New Mexico office. So Dan and Alan, you have the floor.
Thanks, Kelly.
Alan, go ahead.
I'm good. It's all yours, Dan. I'll pop in as needed.
All right, thank you. Again, I did more of a formal introduction last week, but my name is Dan Hahne, and I'm Senior Sales Engineer at Veritech Solutions out of the Phoenix office, and work as the educator with a focus on high-performance HVAC systems, and now with the pandemic, hopefully being a resource here for our design communities on how to reduce concentrations of pathogen in the built environment. Thank you for joining us today, and welcome back for those of you who joined us last week. It's great to have you with us today. And just like last week, the presentations that I've built were due to the generous contributions and the researches and available websites of the manufacturers we represent, as well as ASHRAE's Epidemic Task Force. I want to acknowledge Dry Steam and the material they provided for humidification products. In fact, it was they that inspired this whole initiative back in May with an excellent presentation on the physics as to why properly humidified spaces reduce the risk of infection in the built environment. I want to thank UV Resources for their resources on ultraviolet light and ultraviolet germicidal irradiation, and Global Plasma Solutions for ionization technologies. So for today's presentation, we're going to do a quick review of last week, and then we're going to move into the three main topics: humidification, UV light technology, and ionization. Quickly, I want to touch base on where we first began last week. And that was an introduction, perhaps maybe not for many of you, to ASHRAE's Epidemic Task Force as being an excellent resource for acquiring guidelines to apply good HVAC solutions to reduce the risk of infection with aerosolized pathogens. They offer those guidelines for the reopening of buildings, new buildings, for filtration and disinfection, the transportation industry, and also numerous other resources. Last week's presentation explored a very broad terrain of the politics behind our understanding of how pathogens are spread. And I referenced an article published on August 25th in Time magazine by a professor, Jose Luis Jimenez, that stated that I believe that a substantial share of COVID-19 cases are the result of transmission through aerosols. Professor Jimenez went on to specifically address that he believes that the CDC and the World Health Organization's lack of reference to aerosolized pathogens was a deficiency on their part, and they need to update their guidelines. I also referenced ASHRAE's epidemic task force that has since April of this year always acknowledged that SARS-CoV-2 can be transmitted as an aerosol, as an airborne aerosol. And consequently, I introduced you to the idea or to the most recent guidelines that were modified on October 5th by the CDC that recognizes that airborne transmission of SARS-CoV-2 is certainly a possibility. And so the CDC is updating their guidelines beyond their previously acknowledged fomitic and droplet transmission that we had discussed last week. We then quickly went into ASHRAE's epidemic task force on dilution, how dilution or the reduction of concentrations of infectious disease in the built environment are a way of reducing the percentage of spread among occupants. And we referenced ASHRAE's position document on infectious aerosols and the importance of outdoor air. And the guideline, again, just to quickly touch on it, states that that the guideline encourages building operators to increase their system's outdoor air ventilation to reduce the recirculation air back to the space. The guideline also goes on to state that this must be done as much as a possible existing system will allow for. So I think just to touch on that fact. Also, we discussed filtration and ASHRAE's position on what type of filtration should be adopted or applied for new construction as well as retrofit. And they came out categorically and stated MERV 13 is very efficient at capturing airborne viruses, though we did point out that at viruses of the size of 0.3 microns or less, or any bacterial agent, has only 50% effectiveness of capture. And that's why ASHRAE prefers the use of MERV 14 filtration for enhanced capture rate at the filter media. But we also issued a word of caution that if you're using MERV 13 or MERV 14 filtration in a retrofit application, you need to make sure if the existing air handlers have the available horsepower and the electrical resources to support the increase in static pressure that these filtration systems provide. So just a quick run through of last week. Any questions? Now be aware that Kelly has posted answers to the questions raised during last week's or at the end of last week's presentation, and they should be all available to you, Kelly, if I'm not mistaken.
Yes, I sent a link to all the question and answers to everybody that had registered as of last week. There are currently no questions in the chat box.
All right. Please know that upon review of any of the material, or if anything jars your memory, we're here to answer questions if you think of them after the fact. So don't hesitate to reach out to Kelly, Alan, or myself, and we'll make sure we get you the answers that you're looking for. So on the nature of humidification, in this part of the presentation, we're going to look at the importance of properly humidifying the built environment. We're going to look at the ASHRAE and related humidification studies to give us some context of why this position is held by ASHRAE. We're going to look at the role of humidity in airborne transmission of viruses, the impact of humidity on human health, and how the use of humidification can help reduce the spread of viral and bacterial pathogens. First of all, let's go back to the ASHRAE position document on infectious aerosols. The document references a number of ASHRAE studies. For example, it references the Taylor and Tazi 2018 study that arrived at these conclusions. The weight of evidence suggests that controlling RH reduces transmission of certain airborne infectious organisms. This position document encourages designers to give careful consideration to temperature and RH. The Musavi 2019 study arrived at this conclusion. Scientific literature reflects the most unfavorable, and again, I reiterate, unfavorable survival for microorganisms when the relative humidity is between 40 and 60%. The Taylor and Tazi study goes on to make these statements. These studies showed that relative humidity below 40% is associated with three factors that increase infection. One, infectious aerosols, and we're going to explore what is meant by an aerosol. Infectious aerosols emitted from a primary host shrink rapidly to become droplet nuclei, and we'll explore what that means as well. Many viruses and bacteria are anhydrous resistant. That is to say, they survive in dry environments and have increased viability in low RH conditions. Be aware, we all know our most contagious time of year, such as we're entering now, is also our driest time of year. So be aware of that. Also, the Taylor and Tazi study states relative humidity below 40% impairs mucous membrane barriers and immune system protection, and we're going to explore that in detail as well. Please know that our manufacturer of humidification products is a deep resource on the studies that have been generated over the last 30 years, demonstrating the effectiveness of properly humidified spaces, reducing the risk of spreading pathogens. So let's look into the physics as to why this is. But to do so, we have to make sure we have a common understanding of a term a year ago I was never using. I use it now many times a day, and it's the term aerosolization. Aerosolization is defined as the process or act of converting some physical substance into the form of particles small and light enough to be carried on the air. That is to say, into an aerosol. I've since read other documents that states that allows a particle to behave like a gas. But be aware, the particles we're talking about are being carried on the air when we're discussing aerosolization. Researchers have captured pathogen-bearing aerosols traveling up to 25 feet from a simple sneeze. And what influences travel and evaporation time of that pathogen's H2O envelope or wall when ejected from an infected person are the temperature of the space and the space's relative humidity. And this is where we really begin to delve into the details. And we need to do that to understand why humidification is effective. First of all, let's look at the definition of the term droplet. A droplet is defined as any particle that is 20 microns or larger. Please know, on reading further studies, there are different studies that reference different min-max droplet sizes, but this is a good average size that most studies would reference, 20 microns or larger. To give you a sense of context, a human hair is the size of about 20 to 80 microns, depending on the person. So if we look at the chart to the right, we'll notice that a particle that's 100 microns in size, if ejected into the air, will precipitate and fall to the ground within 6 seconds because gravity acts on the particle, and the more massive a particle, the more influential gravity is on that particle to draw it downwards to a surface. A small droplet or an aerosol is defined as a particle that ranges between 10 and 20 microns. Again, if we look at the graphic, we notice that a 10 micron particle is lighter and is consequently more buoyant. That is to say, its float time in the air is increased. And instead of precipitating to the ground in 6 seconds, It now will reside in the air for 1.5 hours. A droplet nuclei, and this is the critical context we need to remember, is defined as a particle that is of 10 microns, maybe even down to 0.5 microns or smaller. With a significantly reduced mass, we notice that its buoyancy is significantly enhanced and its float time increases substantially, somewhere to the realm of 41 hours. Well, this is very important thing to consider because when somebody is sick and they enter into a space, excuse me, my controls are not operating. There we go. If somebody is sick and occupying a space and they cough or sneeze or talk, or even references to singing, and they release pathogen into the space, because our body is comprised 65% of water, that pathogen is laden with water and mucus, and it's of a large particle size, somewhere in the droplet size. Well, at that 20 plus micron size, the CDC quite rightly has advocated a 6-foot social distancing, whereby outside of that 6-foot range, that larger particle will precipitate to the ground and cease to be a threat to those others located in the same room. If, however, that pathogen is ejected in the space and it's dry, it desiccates. That is to say, that water envelope associated with the pathogen evaporates more quickly. That pathogen becomes less massive, and it stands a greater risk of becoming aerosolized. So at the reduced mass, it will stay airborne lighter. So if you have a properly humidified environment, then that pathogen, that SARS-CoV-2 pathogen, will not shed that water envelope as readily. That water will not evaporate as quickly, allowing the particle to maintain its larger size. If the environment is not properly humidified and it is dry, then we'll see that H2O envelope of the pathogen shed very quickly. That particle, which for SARS-CoV-2 doesn't measure 0.5 microns, it measures 0.125 microns, now is released into the air. It becomes airborne and can travel freely throughout the room and even be entrained within the return air duct serving an air handler. The actual buoyancy rate of a SARS-CoV-2 has been projected to be somewhere in the range of about 72 hours, unlike the 6-second, the 1.5 hour, and even the 41-hour timeframes that we saw in the previous slide with regard to particle sizes. So ASHRAE goes on to state that COVID-19 behaves similarly to SARS-CoV-1, MERS virus, and the H1N1 influenza. It states that the length of time virus is airborne and distance traveled affects spread and severity of infection. It also states respiratory viruses are most harmful when inhaled deep into the lungs, and we're going to explore that in greater detail. And it also states that low ambient humidity causes aerosols to desiccate into virus nuclei that can travel long distances far outside the 6-foot social distancing guidelines. And it's the physics just mentioned that probably encouraged the scientist Dr. Jimenez refers to advance the idea that aerosolized pathogen can contribute to the spread of SARS-CoV-2. So let's have a further look at what happens should a pathogen be desiccated due to an improperly humidified space. What happens? Well, let's go back to a properly humidified environment first. If that pathogen is released and it has that H2O wall or shell, and it's released into the space and the space is properly humidified, and somebody ingests that floating pathogen, because of the H2O envelope, that particle will more readily adhere to the membrane, or to the surfaces of the mouth, to the nasal membranes, to the esophagus, and to the upper lungs. If, however, the space is not properly humidified or the pathogen is desiccated and loses its H2O envelope, it is more readily drawn deep into the lungs where our immune system cannot as effectively deal with it and expel it. The ASHRAE position document on infectious aerosols refers to the Kudo 2019 study that adds this insight as well. Immunobiologists have now clarified the mechanisms through which ambient RH below 40% impairs mucous membrane barriers and other steps in immune system protection. And this is how it happens, or why it happens. If you have a properly humidified space, then the mucus in our lungs, which has a continual flow from the lungs to the upper region of the lungs into the esophagus and out of the person, that mucus maintains the proper fluid viscosity for it to travel easily from the lungs and outside of the body. If you have a dry environment, that mucus achieves a higher viscosity, which means it becomes thicker. It doesn't travel as readily on the cilia in the lungs, and consequently, any ingested pathogen resides in the lungs longer, allowing it to become a greater risk to anybody who ingests it. So with these factors of properly humidified or not properly humidified spaces affect how pathogens can be spread in the space, the Sterling study generated by ASHRAE in 1986 offered this guideline, that the best humidity range for a building to reduce the risk of infection is between 40 to 60%. The Stephen Welty paper, written in 2013 for ASHRAE in response to the H1N1 flu epidemic, came up categorically and offered this recommendation of 50% RH. There is currently a hospital in design by Smith Group in Phoenix that is 150,000 square foot expansion. And the last I heard, it was the engineer's intent to design to this 50% RH humidity. So be aware that these findings appear to be influencing our design considerations of new buildings and expansion and retrofit applications. ASHRAE's 170 guidelines has bumped the minimum RH recommendations from 2013, now in critical care areas and hospitals, to 30%. So I wouldn't be surprised if we continue to see the increase of the minimum RH required in other parts of a hospital as these findings take greater hold, especially since we now have this threat of a pandemic. So the advantages of properly humidified spaces are to reduce the risk of spreading SARS-CoV-2 are excellent retrofit solution. Properly humidified spaces reduce the aerosolization of pathogens by reducing the rate of what is called desiccation of the pathogen. Properly humidified spaces are more conducive to effective immune system behavior. They reduce the lifespan of contagion because pathogens have a tendency to be anhydrous. And it's recognized by ASHRAE through multiple studies over the 30 plus years of its effectiveness. The disadvantages of humidification are the cost of installation and piping, the maintenance factor involved to making sure those systems are operating to maintain the design building RH, and also some of them require RO water solutions, which adds another layer of maintenance to a building owner. So with that, that covers our review or survey of humidification and the spread of pathogens. Are there any questions?
So Alan typed in, does evaporation of the droplet barrier wall affect its float time?
Yes. If the pathogen sheds the H2O envelope or shell that it has when it leaves the body, it becomes less massive, becomes lighter. And as it becomes less massive, it becomes more buoyant, and its float time is increased because it is less likely to precipitate out of the air and fall to the ground.
And Ian said, wow, 72 hours. talking about that same, what you were just talking about. And then Sarah, so to clarify, we are not concerned about RH because of the effect it has on the SARS-CoV-2 particle, but because it is already so small, but rather how low RH affects the human body's ability to fight the virus?
Well, it actually does both. If you have a properly humidified space, the amount of time it takes for the pathogen that when it leaves the body has an H2O wall or envelope, it will maintain that H2O and allow it to precipitate to the ground more quickly and reduce its flow time. If you reduce the RH, that H2O envelope evaporates more rapidly, allowing the pathogen to become aerosolized and extending its float time in a greater threat. As well as, due to a properly humidified environment, the immune system of a person is enhanced because the mucus maintains the necessary fluid viscosity to allow it to freely travel from the lungs and out of the body. In a dry environment, the immune system is less effective because of the higher viscosity of the mucus, preventing its rapid movement from the lungs to out of the body.
All right, awesome. And so Sarah, or anybody else that types in any questions, if you have any follow-ups, you can always unmute yourself or type more into the chat box. Tony, would a humidification strategy then also require continuous RH monitoring?
Yes, but RH monitoring is very common. We see it in all healthcare facilities, and it will allow us to design the amount of water to be delivered to the space in a vapor phase in order for it to provide the necessary moisture levels to maintain an RH set point in the buildings.
All right, that is all the questions in the chat box.
All right, we'll move on to ultraviolet light. So in this section, we're going to cover UV technology and ASHRAE's position documents in reference to the technology. We're going to look at ultraviolet basics. We're going to look at how UV light deactivates airborne pathogens. And we're going to look at 3 acknowledged applications by ASHRAE for the technology as an in-airstream disinfection and induct on-the-fly application. We're going to look at upper air in room disinfection, and we're going to look at a supplemental effect UV light has on maintaining surfaces clean in air handlers where we find the germination of biogrowth. First of all, ASHRAE categorically advocates this position. Ultraviolet energy inactivates viral, bacterial, and fungal organisms so they are unable to replicate and potentially cause disease. And I found in ASHRAE publications many more articles coming forward recognizing the effectiveness of UV light in doing so. Up to this time, however, until I read today in ASHRAE's In Motion publication, which was just released this month, I was not aware of any studies applying UV light to SARS-CoV-2 to see that it is effective. We have plenty of studies to demonstrate its effectiveness on SARS-CoV-2 cousin, coronavirus 229E, but not on SARS-CoV-2. However, I did read in this recent article that Columbia University has ongoing studies of applying UV light for deactivating SARS-CoV-2. And it stated that ongoing studies indicate that UV is very efficient for killing this virus. So very encouraging signs. So first of all, what is UV light? Well, first of all, UV light is a band of energy found on what is called the electromagnetic spectrum. In the realm of the heating and ventilating world, we have 4 means of heat transfer. There is heat transfer by conduction, or a differential in temperature across a uniform body. Heat always travels to cold. You have convection. Warm air rises, cold air falls. You have evaporation, where heat is moved from an ambient air and to allow liquid to undergo a phase change into a vapor. And then you have the electromagnetic spectrum. The electromagnetic spectrum is the one you are most readily aware of anytime you walk outside on a clear day and are irradiated by the sun. The unique characteristic about electromagnetic heat transfer energy is that it's surface to surface. So it only distributes its energy when it comes in contact with the surface. Well, the electromagnetic spectrum is also the energy that allows us to see visible light. Visible light consists of a band length on the electromagnetic spectrum measured by the wavelengths between 400 and 700 nanometers. The intensity of UV light is measured in wavelengths. The narrower the wavelength, the more intensive it is. The wider the wavelength, the less intensive it is. Ultraviolet light resides just outside of the energy intensive violet light. You cannot see it, and it is defined by that discrete bandwidth between 100 and 400 nanometers. UV light is divided into 4 categories. There's UVA long wave light, responsible for skin tanning and wrinkles. There's UVB medium wave light, responsible for skin reddening and more severely skin cancer. There's UVC short wave light, which uniquely is most effective for germicidal control. And then there's the most intensive UV light, which is called vacuum UV. Oddly, the more intensive vacuum UV isn't as effective as UVC for deactivating pathogens. Manufacturers of UV light have standardized on a wavelength of 253.7 nanometers wavelength. And at that wavelength, UVC light acts like a key on nucleic acid molecular structures. RNA and DNA molecules are broken apart at that wavelength. It's one of the beautiful things of physics. It's unique precision and how certain criteria allow for certain types of behavior to occur. So at 253.7 nanometers, UVC light acts on RNA and DNA molecules, breaking them apart, preventing a bacteria or a virus or a fungus from reproducing. Please note, these technologies don't kill a virus or a germicide. They prevent it from being able to reproduce. And if they can't reproduce, they are inert to anybody who might ingest them. Different pathogens, however, respond differently to the same intensity of UV light. And a manufacturer will assign a K factor, a multiplication factor that'll define what intensity level the UV light needs to be designed to for it to be effective in neutralizing pathogens. The good news is that viruses are very susceptible to UV light. Consequently, their application during this pandemic and even flu season makes all the sense in the world. Your more complicated germicidal structures, such as funguses and bacterial spores, are more complex and require higher intensity levels of UV light for them to be effective. To demonstrate or give you an example of what type of energy levels we are talking about, for UV light to be effective on coronavirus, an intensity level of approximately 2,000 microwatts per centimeter squared of surface area will allow for a 99.9% coronavirus deactivation rate. So it's very effective, and this occurs within seconds. That's one of the beauties of UV light, is it's very quick on its deactivating pathogens. If you wanted to address influenza, you would want to enhance the intensity 6,600 microwatts per centimeter squared. And then depending if you wanted to actually address levels of bacteria or fungus, you would again increase the intensity. UV light, however, for it to be effective, requires a direct line of sight from the UV generator to the area, to the surfaces, or to the airstream it is trying to act upon. If you install a UV light generator in a ductwork in an on-the-fly application, that generator will lose its effectiveness should there be a 90-degree duct transition downstream of the generator. And as soon as the air loses its direct line of sight to the generator, it is no longer being acted upon by that UV resource. So we can actually put it in the airstream, and we can put it into air handlers to not only irradiate the air for on-the-fly applications, but also to prevent any buildup of germicide on surfaces. Consequently, we more often than not see a UV light installed in an air handler on the downstream side of a cooling coil, where we have an area subjected to high moisture content that is conducive to breeding bacterial growth, also known as biofilm that can congest cooling coil that could actually restrict the free area in a cooling coil and prevent the heat transfer efficiency, as well as run the risk of sending bacteria free floating down the airstream. If you use the technology in the duct for a retrofit application, there are certain design factors to keep in mind. One is, what is the velocity flow rate of the air? The amount of time the air is in, has a direct line of sight to the generator, the more effective the generator is on neutralizing the pathogen. We need to look at air temperature as well. If you install a generator on the downstream side of a cooling coil, you need higher intensity because at that colder air level, the UV light is not as intensive or as effective than if you mounted upstream of the coil, where with a higher temperature, you can use less energy for the same effectiveness, but you have other concerns. You need to make sure that in that installation upstream of the coil, you are not irradiating filter media, which will degrade over time when subjected to UV light. Also, it'll actually act upon internal air handler insulation and gradually break that down over time as well. The different types of material that UV generator will be installed in will affect the intensity level. If you mount it in the duct in an on-the-fly application in a galvanized duct, you would take your intensity level and multiply it by 1.5. So you can increase the intensity by mounting it in galvanized duct. If aluminum has a factor of 1.75 and stainless steel, I believe, has a reflectivity factor of 1.4. So all of this is taken into consideration of designing a UV generator with the appropriate intensity to optimize its effectiveness in deactivating pathogens. ASHRAE recommends in-duct disinfection, both in air handlers as well as in the ductwork in an on-the-fly application, but it also recommends two things: that you not install it in an air condition that exceeds an airflow velocity of 500 feet per minute. Our manufacturer, UV Resources, will not look at it if it's to be applied in a ductwork that has a velocity greater than 1,000 feet per minute. And depending on that air velocity, we can increase the intensity of the generator for faster moving airstreams to maintain its effectiveness. But again, ASHRAE's recommendation is 500 feet per minute. And it should always be coupled with mechanical filtration, such as MERV 13 filtration. If you wanted to use it for an immediate retrofit application, manufacturers make in-room UV light generators. These devices are to be mounted above 7 feet into the room, and they have baffles to make sure the UV light is cast straight across the room or into the upper levels of the room to prevent occupants being subjected to that UVC beam, as it can be and will be a health hazard over prolonged exposure. Be aware that if you are going to apply the technology, you want to make sure that you have sufficient air churn in the space, so you're always exposing any germicide that's been ejected into the space into that UV beam. If you have a stale, stagnant environment, then a lot of that pathogen will not be subjected to the forces of UVC light. So ASHRAE's recommendation for the application of in-room irradiation with UV lighting are consider it for a space where you have no mechanical ventilation or limited mechanical ventilation available. In areas where you have high occupant density, such as emergency room waiting rooms, conference rooms, classrooms, or other high-risk areas. ASHRAE recognizes that UV light technology is a cost-effective first approach for reducing concentrations of active pathogen, but it offers these design guidelines. Consider the reflectivity factor, or the UV reflectivity factor of walls and ceilings. If you have high reflectivity, since UV light is a vector force and travels in a straight line, it could be reflected in a way that it does reach the occupants in the room below. So we need to be aware of the surfaces in that space. We need to be aware that the ventilation in the space is maximized, creating a maximum mixing. So we're always exposing room side pathogen into the UV beam. And where there's insufficient ventilation, to consider the use of supplemental fans, such as ceiling fans. I do suggest, though, that if you are considering upper room and in-room disinfection with UV light, that you consider the HVAC system. Remember, and we're going to cover this in greater detail next week, but just to give you an idea, most of these systems are designed to provide the amount of induction of room air into the supply jet at 100% of flow. So the question I'm going to leave you with was, how often does that VAV box open 100%, or is that package DX unit fan operating during occupied hours? Because if you have reduced flow out of a diffuser, you have reduced room side air induction into the upper levels of the room, and consequently less pathogen exposed to the UV beam. UV light, ASHRAE also recommends using UV lighting technology to keep coil surfaces clean, to make sure that that discharge area is subject to condensing water from water condensing out of the supply airstream does not result in the germination of bacterial growth and bacterial mass. And UV lighting has been proven to be effective in preventing that from occurring. So you are not running the risk of germinating biofilm that will restrict the free area of coils and allow for free floating bacteria to travel down the duct and into the building. ASHRAE recommends using UV lighting for coil surface cleaning. In air handlers, they recommend around the cooling coils, as we mentioned earlier, and wetted surfaces for reasons expressed. It also advocates that if you want to also use it for on-the-fly application, to increase its intensity for it to be effective. And then it offers this insight. ASHRAE says that you design your UV light generators to provide even distribution across a coil face. Mount the devices 12 to 36 inches from a coil face, but I was just talking to our manufacturer today. They can work below 12 inches as well, providing they have a good understanding of the type of unit they're designing to. But ASHRAE also recommends that if you're using the technology, let it run through the night. Let it act on the room air over the night when the building's not occupied. So any buildup of pathogen concentration during the day will be significantly reduced, allowing for a clean building in the morning when occupants come back to the building. So advantages of ultraviolet light are, it's an excellent retrofit solution. It reduces the pathogen deactivation time, seconds, not minutes or hours. There's no increase in system static pressure, and it's recognized by ASHRAE as an effective technology for deactivating pathogens and germicides, as well as it's recommended for deactivating SARS-CoV-2. Utility companies are now considering rebates. I should have updated this slide. We now know that our local utility, Salt River Project, is offering a $30 per ton rebate for an HVAC system designed using UV light technology. So we're seeing more incentives happen here in Arizona. The disadvantages are, for UV light to be effective, a direct line of sight is required from the generator to the area to be acted upon. UV lamps have a D-rate factor of 10% per year and the bulbs need to be changed out once a year. So it's a very easy process, but again, there's a maintenance factor to be factored. And if the lamps aren't maintained, the effectiveness might be derated sooner, so you may have more than once a year changeouts if those lamps are not maintained. If you're using it for in-room applications, you need to be aware of exposure to occupants, and there's no conclusive testing of its effectiveness specifically on SARS-CoV-2. Any questions on UV lighting?
Yes, we do have some questions. And also, I just saw something come from UV Resources that just because you see a light coming from the bulb does not mean that it is still actively working. So it's not like your typical light bulb where it burns out and you don't see the light. So I just saw something from them in one of their newsletters. So very interesting, I thought.
Thank you.
Let's see. So Alan, can a UV induct application be calculated for effectiveness? Induct, yeah.
Yes. In fact, I'm working with an engineering design team. Currently, they send us the design parameters, give us the consideration as to where they want that UV generator located, whether it's in the supply duct or in the return duct. They're looking for direction on what air velocities to design to. Also, they have let us know that it'd be installed in a galvanized duct, so we can actually take any intensity level of the generator and multiply it by 1.5 to determine how much intensity is actually needed to act effectively on SARS-CoV-2 or any other pathogen in the space or in the supply air stream.
All right. Alan, did you want to add anything to that? I saw you come off mute. Okay. From John, let me make sure I'm in the right spot. How fast is the filter degradation? Is it still a consideration with 1 to 3 month change out?
I don't know. I don't have an answer for that. Kelly, we should take note of that and get an answer.
Okay.
I do know it's my understanding you can buy MERV-13 filters with UV light inhibitors to reduce the rate of degradation, but I don't know how available they are, and I don't know which filter manufacturer would actually provide them.
Yep, we can definitely look that up and provide that in our follow-up. You stated that the UV intensity and dose is dependent on air temperature. Can you please explain why? That's from Clifford.
The air temperature impacts the intensity production of the lamp, and specifically. In fact, I just confirmed that this morning. At a warmer temperature, the lamp itself is more effective in achieving the required intensity levels. For a colder condition, the lamp is not as effective in generating the intensity level.
Okay. And then Clifford also has a question that he said would be better asked verbally. So Clifford, you can go ahead and ask.
Thanks, hey, Daniel. With UV, especially with the upper air UV, it seems like the contact area, the dose is really limited. The radiation, drops off to R squared or R cubed. And do you have any studies that you've seen that shows how effective these are if you're trying, how long it will take to actually purify a room? How many air changes would it take?
In fact, excellent question. In the ASHRAE In Motion publication I just read this morning, there's a direct correlation between in-room irradiation and air change rates. By applying the technology, you can figuratively look at increasing the air change rates, and some values are given on that. And Kelly, I'll be happy to share that literature with you, and I'm sure our manufacturer UV Resources can help us do that. But let's go back to how a UV in-room generator is designed for a space. Its sizing is based on total effective square footage of area covered. There's a size 150, a size 250, a size 350. So depending on the geometry of the room, our manufacturer is stating that lamp will be effective over that square footage of area. So again, depending on how large the room would determine how many units and which size of units would be applied in that room. And by doing so will result in effectively an increase in what otherwise would be required for air change rate, an increase in air change rates.
Quick follow-up. I wonder if those studies assume well-mixed conditions. My concern is if the UV lamp is in a stagnant region or depending on the flow patterns, the actual exposure may be limited. Do you know what I mean?
I know exactly what you mean, and we're going to cover that next week because I have a couple of solutions. But ASHRAE does recommend where you have areas with low churn or low velocity air, use ceiling fans to make sure you're creating the mixing in the space to expose pathogen to the UVB.
Thank you.
But I'll be covering that next week on a solution for variable volume air systems to maintain churn of the space at 50% or 25% of flow to the space. Yes, that'll be part of next week's topic.
All right, and I made a note of those two questions so that we can include them in our Q&A follow-up. Let's see, Alan, are UV bulbs considered hazardous waste?
And I would say yes, because I believe they're mercury gas. Think of them as like a fluorescent tube without the UV inhibitor on the inside of the fluorescent tube. They are, I believe it's a mercury type gas that's used in that technology, so it would be considered a hazardous waste.
All right, that is all the questions in the chat box.
All right, let's move on to our final topic today, which is ionization, which begs the question, is the only solution for pollution dilution? So what are ions? Ions are naturally occurring elements. They exist throughout the universe. The photograph of the right I took 5 years ago of the Orion Nebula, the blue gas illustrates ionized oxygen. The red gas is ionized hydrogen that is irradiated by intensive radiation from star forming regions within the cloud. So, oh, wait a second, did I pass the slide? No, let me see here. So ions are also naturally occurring on Earth, and you can see them higher concentrations of ions in higher elevations. We associate mountain air with clean air because the higher concentration of ions act as natural air scrubbers for reasons we'll see shortly. We also see them located along the beach or wherever there's a turbulent water source, higher densities of ions. At upper elevations, such as Flagstaff, we can see ion densities of approximately 3,000 ions per cubic centimeter. In the city at sea level, we'll normally see probably about 200 ions per cubic centimeter. And the reason why there's this reduction is because UV light from the sun actually strips electrons from free-floating particles in the air, causing ionization to occur. Well, atmosphere and ozone are UV inhibitors, so the more atmosphere light has to pass through, the less intensity, and consequently a reduction of ionization at lower elevations. In buildings, however, there are less than 100 ions per cubic centimeter because there's very little to no UV light available. So the question is, what if you can create ions artificially? Can you create better indoor air quality in a building by doing so we can simulate higher elevation ion density levels? And the answer is you can. So first of all, what is an ion? An ion is an atom or a molecule with a net electric charge due to the loss or gain of one or more electrons. If you have the ability to cause ions to form artificially in a building, you can artificially create better indoor air quality. So the one specific particle that is optimal for doing this is the available water vapor in the air. If you can break apart an H2O molecule into its hydrogen and oxygen ion constituents, you can create what are called ion plasma fields. And the technology that we have used at Veritech for the years is needlepoint bipolar ionization. What is needlepoint bipolar ionization? Well, if you can create free-floating ions by providing a high voltage to positive and negative emitter points on a device, those opposing forces will act upon free-floating water vapor and break that molecule apart into oxygen and hydrogen ions, creating what is known as an ion plasma that fills the supply airstream and consequently is infused into the built environment. And this process is called bipolar ionization. One of the byproducts of saturating a room with ions is a principle called agglomeration. Free-floating ions will positively and negatively affect particles free-floating in the air, and wherever those particles gain a positive or negative charge, they will more likely come together, allowing for what is called agglomeration to occur. So free-floating particles and dust particles will actually be drawn together. They can become larger, and what otherwise might require MERV-8 filtration can be enhanced to MERV-13 filtration. And I think if you do that, however, your filters are going to have to be changed out more readily, like we found with MERV-13 filters last week and some of the questions raised. So agglomeration is a natural product of ion plasmas in the built environment, allowing for cleaner air. Ions will also act on volatile organic compounds, otherwise known as VOCs, or off-gassing from various surfaces and bioeffluents of occupants in the space. If you have a technology that can actually pull apart volatile organic compound molecular structures without acting on oxygen, you can actually reduce the concentration of VOCs in the space without creating ozone. Well, it just so happens that hydrogen and oxygen ions subscribe to that 12 electron volt threshold. And at that threshold, it'll act on any VOC with electron bonding potentials of 12 electron volts or less. If greater than 12 electron volts, you break apart oxygen. And the byproduct of breaking apart oxygen is ozone. And that's a challenge with some ion generating devices. So to give you a dynamic graphic, if you have a VOC come in contact with an ion plasma field, it is actually deconstructed into its ionic constituents that then reform into more inert elements that cease to be a health hazard to occupants. So that's the critical threshold, 12 electron volts. There are manufacturers that there are ion generating manufacturers that apply the technology that require higher voltages. The question you need to ask is whether or not it will consequently produce ozone as a byproduct. Another byproduct of hydrogen and oxygen ion plasma are the formation of hydroxyl radicals. Hydroxyl radicals are negatively charged molecular ions that are looking for electrostatic equilibrium. And to do so, they need a hydrogen atom. Well, the available resource of hydrogen is to be found in the nucleic acids of germicides. And those hydroxyls will surround a germicide and pull out the hydrogen in that nucleic structure in the RNA and DNA, rendering them inert and allowing them to consequently cease to be a risk to the individuals in that space because they are unable to reproduce after that point. There are independent third-party test labs that have proven the effectiveness on ions, on deactivating E. coli, MRSA, even TB, which is a very resilient virus. And it is very effective in acting on coronavirus 229E. So we do have third-party testing on that. And we now have tests to demonstrate that ionization is effective on deactivating SARS-CoV-2 at ion density levels of 27,000 ions per cubic centimeter. And you can see that in 30 minutes at that ion density that was determined to serve the airline industry for a jet traveling at 30,000 feet, where ion density levels are inherently higher for reasons expressed, we are seeing deactivation rates of 94.4%. We have just received studies that showed that, again, for the aviation industry, ion technology will deactivate SARS that has been aerosolized and precipitates out onto surfaces. And innovative bioanalysis test lab tested fomitic transmission off of 3 different types of materials: Kydex plastic, aluminum, and leather. And at ion density levels of 26,000 ions per cubic centimeter, SARS-CoV-2 was deactivated 99+% of the time within 30 minutes. The CDC has updated its language to state that bipolar ionization has been around for decades and has matured in many ways, so the potential safety risks have now been resolved. It does state that if you are considering the acquisition of bipolar ionization equipment, you'll want to be sure that the equipment meets UL 2998 standard certification as a non-ozone generating device. Please know that Global Plasma Solutions, a manufacturer of ion generators that we represent, does carry the UL 867 and the UL 229 certification for non-ozone production, subscribing to the austere 5 parts per billion generation of ozone required by that standard. We are also working on technology at Veritech that'll allow us to measure the effectiveness of ion generators. We represent a line of cloud-based controls called Riptide. It can take full HVAC control of a building using cloud-based technology, and we can now generate VOC concentration displays on its dashboard, ion density levels on its dashboard, and can calculate an IAQ score as well. So the advantages of ionization are it's an excellent cost-effective retrofit solution, no increase to system static pressure, maintains effectiveness in the occupied space and beyond. It has been effectively tested for SARS-CoV-2, and it could be an excellent scalable solution for new construction using VRV technology. The disadvantages: ASHRAE recognizes ionization as an emerging technology and does not offer a categorical statement regarding its effectiveness as it shares with UV light. Questions?
All right, so we have a couple in the chat. How does space humidity affect the ionization process? From the first slide, it would appear that higher humidity benefits the process.
Kelly, can you repeat that? You broke up on me a little. I didn't hear the whole.
How does space humidity affect the ionization process? From the first slide, it would appear that higher humidity benefits the process.
Actually, what it is, it's the discrete threshold of what is the minimum humidity where it ceases to be effective. If there is an RH below 10% at the ion generating device, we will begin to see some very modest reduction of ion density production. But that is a very rare condition, but we can certainly design to that by increasing the size of the devices that we use to increase the concentrations of ions produced. So higher humidity does it actually add to perhaps higher ion densities? And very logic would seem to say yes, but I'm more aware of what the critical minimal threshold is, which is an RH of 10% before we see a degradation of ion production that falls in line with design considerations.
Okay, and we have one more question in the chat. What is the target ion density for equipment selection?
GPS is now recommending an ion density for the space of 2,000 ions per cubic centimeter. Veritech has installed 2 iMod generator devices on two 60,000 CFM air handlers serving our office. And we're reading in the building 4,500 ions per cubic centimeter. And what's been fun is actually measuring an ion density level of 2,000 ions per cubic centimeter in the return air duct. So right the way through the space, ions are acting on any free-floating pathogen, any VOCs, and enhancing filtration through the principles of agglomeration.
All right, Aaron Aguilera, does Veritech offer a way to measure IAQ ventilation rates since NPBI works best when reducing outside air?
Not at this time.
Okay. That is all of the messages in the chat. As we're
hey.
wrapping up. Oh, yeah.
Kelly or Dan, so we can actually measure ions in the space. So there are ion meters. We here in our office here in Albuquerque, I think in Phoenix as well, we have a portable handheld one.
That does sound right. I did see, I think.
And there are also meters that can be permanently mounted. It's not necessarily about the reducing the outside air, even though that is a side effect of something we can do and still provide excellent indoor air quality. Right now, the real focus is the ion density to ensure that we're mitigating any pathogen that may be in the air.
So Aaron followed up, this would be comparing outside air to ASHRAE 62.1.
Yes, but let me offer this qualification and add to Alan's excellent point, and I failed to mention this. Code, certainly the city of Phoenix recognizes that if you use a GPS ion generator, you can use ASHRAE 62.1's IAQ procedure for calculating your ventilation air versus the ventilation rate procedure. And we're seeing outside air reductions of 50%, sometimes more, depending on what building is being served and how it's being used. Yes, you can. But now we have the question with the pandemic that is advocating for more outside air. How does that balance against generating the right ion density levels in the space? And how can we translate that to air changes per hour enhancement by using the technology? So a lot of questions here that we will be evaluating in greater detail moving forward for sure.
Right, and we have, we've seen that in Phoenix. So I'd be curious, Alan, if anybody else has any input about what New Mexico is seeing with their city codes, or, I know we have people from the Lubbock area and the El Paso area as well on this call.
As a general rule, it depends on which code. And I always get them confused, but one of the version, and I can't remember if it's the Uniform Mechanical Code, does not allow for the use of the alternative ventilation calculation. So we can operate in that mode. The code itself does not allow for the use of the alternative outside air ventilation procedure.
Okay. Yeah, so that's something that, based on your local codes and jurisdictions.
Yep.
And then
the local authority determines that.
Yep.
And then Brandon commented, did you say 50% outside air reduction?
Yes.
That is correct.
John, do you know why ASHRAE calls bipolar ionization an emerging technology? It seems like we have been using ionization for decades in clean room applications. Which is true. It has been around for quite a while.
Yeah,
Well,
I think.
Go ahead, Alan, you go ahead and answer this.
John, John, I think part of the reason is really ionization as a general technology, going from what we originally had as ionization to the bipolar ionization, where we've mastered not, of keeping our electron voltage under 12 is actually the newer part. We've had ionization since the 60s, and it's been well used. The problem is, as we get above that 12.07, then we start generating ozone. And so that's where to me, that's kind of why, to me, ASHRAE has not really fully vetted out the bipolar ionization with the caveat of the UL certifications. Dan, you have anything to add to that?
Yeah,
No, Alan, you're absolutely right. But every time I go back to ASHRAE, they are expanding its adoption of ionization. In fact, the guidelines for the reopening of schools generated by ASHRAE at the end of July of this year said that where MERV 13 filtration is not possible due to the restrictions of the mechanical system, give ionization a consideration for improving indoor air.
John, did you want to add
Oh.
something to your question?
no, I would like, you said that was the July bulletin from ASHRAE. Yeah, if you have a copy of that, that would be good. I'm trying to use it as argument in support of ionization, bipolar specifically, but yeah.
So where
I know-
ASHRAE is mentioning
Yeah,
ionization?
I still doesn't really explain why they're calling it emerging, other than what you said, Alan, that it is a bipolar and an electron volt limiting version of it. But other than that, the technology itself is been around. So I don't know why
I agree.
call it.
And I think, a lot of it gets down to ASHRAE. ASHRAE itself has not spent the time to do their
Testing.
search.
Yeah.
Yeah, so a big one is the UL listing for the ozone.
Yes.
Right.
Yeah.
Well, we have some pushback from some designers that we're fighting. So yeah. Okay.
Get
Thank
you
you.
any information, all the links where it shows ASHRAE referring to ionization.
Yeah, and John, I'll send you something else too. I'm more aware of that fight that you had with another designer of late regarding ionization, because and I think it's, as mechanical engineers, I think most mechanical engineers are risk averse, and what we're finding is, some are just not. If ASHRAE doesn't recommend it, then they just, they won't consider it. But I think that the big key is the change of ASHRAE state from, their original documentation regarding opening schools of not including bipolar ionization to the version, I think it was in July, or, that did include bipolar ionization as an option if we couldn't do MERV 13 filters. So I think that's kind of to me is the real key, is that ASHRAE is beginning to understand and accept bipolar ionization as a valid and certainly a legitimate means of mitigating pathogens.
Great. Thank you, guys. Appreciate the feedback.
So before I go to the next question, since we did run a little bit over, Dan, I want to let you plug next week. But before that, to anybody on the call, I know that we covered a lot last week, this week, and we're going to cover even more next week. So if there is any topic in particular, so let's say you wanted to do a deeper dive on ionization or humidification or UV or any of the individual topics, just reach out to Alan or your salesperson with Veritech or myself or Dan, and we can certainly do a deeper dive on any of these topics, because I know it's so much. So I just wanted to throw that out there. And Dan, if you want to talk about next week before we go on to the next.
Well, absolutely, and I appreciate your patience with this data-intensive presentation, but I don't know how else to go about it without digging into the weeds of it. Next week, we're going to explore a topic that we began with an excellent question on in-room UV. We're going to look at airflow patterns and how airflow patterns affect the indoor air quality of a space, and perhaps some technologies to consider to overcome the challenges of part load. We're going to look at indoor air quality and what that is, and then we're going to evaluate a system integration approach, where a layered module approach of applying any of these technologies in a combination of them to enhance the actual effectiveness of their performance. as well as some innovative new HVAC design considerations, such as 100% outside air systems, displacement ventilation, et cetera. So we'll be going through that next week. And thank you so much for your time today and interest in this presentation.
Awesome. Thank you, Dan. So I want to wrap up with a few questions so that we have them recorded. So if you do have to leave, we understand we did go a little bit over, but we are going to send out all of the questions in writing, and we will stay on right now if you do have time to listen to the rest. This question is from John Reese. He said, how do these technologies relate? Should we use all three in the same application, or is there one primary measure that is a priority-based measure? So I think that's a perfect lead-in for next week as well.
Certainly it depends on the space as well, but I think uniformly to create not only the best indoor air quality as well as reducing the spread, but humidification seems to be just proven to be an effective resource. However, there's a cost associated with that and a maintenance program as well. Other than that, all of these, depending on the application, have their advantages and disadvantages to some extent, which I hope I was able to briefly point out in the summary for each section.
Yeah, and to his point, using all three in the same application, layering them together, integrating them together also has its benefits.
Absolutely, and we'll explore that in greater detail next week.
All right, so we have a few more questions coming in. How about a cost comparison between UV and bipolar and the air handler? I don't know if that's something, Alan, you wanted to cover separately.
On an initial cost standpoint, they're relatively close to the same. A couple of cost estimates I've done, they've been relatively close to the same initial cost. The real difference in the two really becomes a life cycle cost, with UV requiring yearly bulb change out. So you have a maintenance standpoint that goes with that and just the bulb cost. It just kind of becomes an owner preference.
Okay. From Chris, ionization is the method that I have the least familiarity with. What is the practical application of it? For example, the UV is an accessory inserted into the airstream. Is this similar with ionization?
Well, Alan, go ahead.
Yeah, Chris. So yes, absolutely. It's very similar to UV in the way it's applied. In duct, in air handler. One of the differences is we like to actually mount it on the upstream side of a cooling coil rather than the downstream side, simply because it allows us to have that strong high ionization field move through the cooling coil to mitigate any of the biofilms that may be trying to develop. We find the cooling coils historically are basically they're a biological trap in an air handler. And so, in the same way UV's used on the downstream side to mitigate any biological items that develop, we want to use GPS or ionization on the front end of the coil, but you can also apply in your ductwork. The big difference is ionization does not have to be in direct contact. In other words, you don't have to be able to see your GPS, your ionization device, for it to be working. The ionization plasma field actually gets pushed through your airstream with your HVAC system just via airflow. So hopefully that helps clarify.
All right, so that was the last question. If anybody does have any other questions, feel free. And Chris did say that is helpful, thank you. Feel free to reach out to any of us. Like I said, I will be sending out a link for the recording and the slides and the Q&A that we just went through. So if you have any other questions, just let us know and we can cover those as well.
Thank you all for joining us.
Yep, that's all we have. So thank you guys so much.
Thank you very much.
We'll see you next week.
Bye-bye.